The next question we need to ask ourselves is, what are pointers? What are they? Well, why do we need them? I mean, we understand that pointers point to some other data, some other variables, but on the more higher conceptual level, what are pointers and why do we need them? When we come to discuss the meaning of pointers, so the normal answers that we usually get is efficiency, or for, instead of copying value, the entire object, you can copy, just a reference to it, which is all, it's all true. But it's not what a pointer is. What a pointer is, in a sense, is a way of creating an L value from a different value. What I mean to say is the following. An L value is, in a sense, a locator value. That's the real name, but it lost the real name a long time ago. And today, L value just means the left-hand side, and R value means the right-hand side, right? But actually, L value means a locator. And what that really means is the following. Let's go back to the blackboard. Let's go back to the drawing board. There are values, as we learned, of course, in compilers, there are values that can be placed on the left-hand side of an assignment. And there are values that can only be placed on the right-hand side of an assignment. Let me give you an example. The number 5 cannot be placed on the left-hand side of a value, of an assignment. You can't write 5 equals A. Now in mathematics, that does make sense, because in mathematics, this is an equation operator and not an assignment. But in programming, this is an assignment operator, and an assignment operator must get an L value on the left-hand side. Now, as I said, L value does not stand for left value. It actually stands for locator value. But because, and R is just because this was L, this became R. R doesn't really have any real meaning. It's just, this was a locator value, and therefore it got the name L value. And once that became the L value, the other side became an R value. So what are L values and R values? So we learned in compilers that L values are, in a sense, values that can store data for future use. That's an L value, right? An L value is something that we can actually references a real memory reference, a real memory location that can retain its memory for the next command, in a sense. That's an L value. Right? That's what's called locator value. It has just the name of a variable, in a sense. It's an address, it's a memory address. While an R value is just a value. Now, it could very well be that you can put an L value on the right side too. So we could write, for example, C equals B. Now, it's true that this is also an L value, but it's not being used here as an L value. It's being used here as an R value. I mean, it's just being computed as a value. So therefore, for example, you cannot write. You could write, for example, C is equal to A plus B, but you cannot write that A plus B is equal to C. So even though A and B are all L values, in a sense, A and B are L values because they can store data for future use, but the result of the addition operator is an R value, which means the result coming out of this is it's an R value. It's not an address. It's just a value. And that cannot be placed on the left-hand side of an assignment operator. So once we just, recapped on L values and R values, let's go back to our original discussion. What are pointers? Pointers are a way of turning in a sense, name of a variable into an L value. And let me explain that in different terms entirely. Suppose for a second and I'm going to deviate to an entire different type of discussion. Suppose for a second that one wanted to calculate during runtime which value to use. Notice not what the value is, but which variable to use. I want during runtime to decide whether I want to use variable A or variable B. Variable B. Now, there's no real way of doing that. Think about it for a second. You can write if some Boolean expression, then use A use B. But notice that both the path for both A and B is already in the code. Meaning I can go into the code and I can say, listen, if some Boolean value, right? Then use the variable A for everything you need. Else, use the variable B for everything you need. Now, I'm not really making a choice between variables. Both paths are in the code, meaning that if you look at the code, they are both there, which means you're not calculating the name of the variable. What I mean to say is you're not calculating which variable to use. You are just based on some kind of Boolean expression, deciding which path of the code to take. It's not the same thing like saying 3 plus 5 and you are getting to 8. 8, if we write in the code somewhere 3 plus 5, right, and the answer is obviously 8, the number 8 does not exist in the code. The number 8 is calculated by the code. Now, if we try to emulate this, using variable names, notice which variable to use, not the value of the variable itself. I want to use A, I want to use B. Make some kind of calculation and tell me which variable to use. You can't do that. Well, you couldn't do that until pointers. If you think about it for a second, until pointers, you are not able to actually go and decide which variable you want to use, which means in a sense, turn the variable names into lvalues in the sense that I can put them, I can calculate who to use and use that for as an lvalue in an expression. So in a sense, this does not constitute calculating variables. You're not doing that. Both paths are in the code. But when I go and I say, listen, here's a pointer, use the pointer. And then I can figure out mathematically, for example, that this should point to there. Or it should point to there. And this I will do in the code. Now this, let's say, is A and this is B. So notice that I am calculating which variable to use. So by having indirect referencing of the variables, or in a sense the variable names if you want, which variable to use, what I'm getting is a way of deciding programmatically which name I want to actually use within the code. This, the right hand side, is not, this thing right here, is not equivalent to that. They're not equivalent. Right? This is not equivalent. It's not the same thing at all. In the left hand side, as I said, all the paths are in the code. You're just deciding which path to take. In the right hand side, you are calculating in some manner or fashion which variable to use. Now let me give you another example which will make more sense. Let's look at an array. If I have an array, let's call it ARR. So this is 0, 1, 2, 3, 4, and 5. When I write in the code, for example, ARR3 is equal to 17, everybody agrees that the ARR3 is an lvalue. You can store 17 in here, right, for future use. Now, what is actually going on in this ARR3, right? I can also say, listen, cout, please enter a number. I can enter the number into this, and I can say use ARR I, whatever I is, enter into I mod 6, assuming it's a positive number here, to get myself one of these values, right? I'll get any one of these values, and let that equal 17. Now notice that I do not know during compile time which value will be used. Notice there are no multiple paths. It's the same path. There's only one path here. And during runtime, I get to calculate which variable I'm using. This one, this one, this one, this one, or that one, right? That I'm getting during runtime, right? I'm getting a calculation of which operand I want to use, which is not something that I was able to do using all kind of conditionals or whatever it is. It's only true because of pointers. Now, the way this works, just to make us more begin to make our understanding better, the way this thing works, in a sense, is that what we see here is, in a sense, is ARR plus I mod 6, all of this dereference. This is what this is, right? Now, writing I mod 6 just so whatever the guy gave us would be illegal, so let's just change that a second, and let's assume that he gave us a 4, just for the sake of discussion. So let's assume that he entered a 4, right? So notice that I did not create multiple paths in the code. What I did is I was able to run calculations on the variable I want to use. Now, there was no way of doing this without pointers. This is just a regular pointer, that's all it is. Right? It's ARR is the pointer this way. That's what it is, right? And I'm using the ARR pointer style syntax in order to show this. But instead of using the array syntax, is the exact same thing because the compiler just changes to the right this that. That's all it does. Okay. So what we're doing here is we are calculating names, or if you want, we are calculating which lvalue to use, which is something I could not do without pointers. So if we had to sum up what is exactly a pointer is a way of taking a value and turning it into an lvalue, meaning to say that I can take the value, whatever it is, I don't know, some address. This is just a number, right? I can take this as just a number, and I turn that into an lvalue, meaning that if it was just a value, I couldn't write whatever this value is equals 17. I couldn't write that because you cannot, because a number or a value is not an lvalue. A number, just like 5 in the previous slide that we had before, the number 5 is not an lvalue. The number 5 is an rvalue. So you cannot go and put value to the 5. But if I go and I say, listen, this is just an address. So what I'm actually saying is, just assuming the address 5, yeah. So what I'm actually saying is, I am taking some kind of value, any value, and turning it into an lvalue, going back to our previous discussion. So notice the interesting way of what pointers give us is actually an interesting way of turning values into lvalues, obviously in a controlled fashion, meaning that you cannot go and just do whatever you want. But what I'm saying is I'm using it as an address to some location. And that's what pointers give us. If we did not have pointers, you couldn't do that. You couldn't put a value, which is an R value, on the left-hand side of an assignment operator. This is obviously used in arrays, like we said before, and also in other mechanisms, but it's actually a very, very powerful mechanism. Now, as a side efficiency issue, yeah, we get efficiency also. We can transfer addresses of objects and stuff like that. But it's not what a pointer actually is. What a pointer actually is a method of calculating names of variables. When I say names, I don't mean the name. I mean what the name represents, which in a sense is the address of, which is something I couldn't do without pointers.